Hello everyone and welcome back. Today we are going to talk about vertical projectile motions. So basically on vertical projectile motions we are talking about motions of objects that are projected vertically, meaning the objects can either be projected up or down. So I would like you to note the following. For example, in this chapter, air friction is going to be ignored. So we know now when you project an object upward, it will encounter air friction. But we are going to ignore the air friction. The second thing to note is that a projectile is a free fall. So basically, the only force that will be acting on the object that is projected, it will be gravitational force. So that means an object will only be influenced by gravitational force. Remember, gravitational force is a force that attracts everything towards the center of the earth. So it means now, if you can see the circle that I've drawn here, the outside circumference represents the surface of the earth. So if a person is standing here, he wouldn't be able to fall down to the other side. Or even if the person is standing down here, you wouldn't be able to fall on the other side. It's because of this force of attraction, which is called a force of gravity. So basically, the force of gravity is pulling everything towards the center of the earth. That is why when you jump, you come back to the surface of the earth. Is because of what? Of this force of gravity. The next point is that the acceleration of a projectile is always 9.8 meters per second squared, and it will always be acting downwards. So like we said on the first point to note, air friction will be ignored. So that means the only force that will be acting on any projectile that is projected vertically, it will be gravitational force. And then always this object will always accelerate with an acceleration of 9.8 meters per second squared, and they will always accelerate downwards. Okay, so there's a difference between a velocity and acceleration. So basically, a velocity is a rate of change in displacement. Okay, let me just explain here. So velocity is a rate of change in displacement. So that means every time when you move particular steps or a particular distance, you are actually changing the displacement, and every time when you move, time is always moving. So that is why we are saying velocity is a rate of change in displacement, because when you make a movement, you're actually changing the displacement, and then time is also changing, and then that causes a motion of which we call a velocity. But you must be aware to know that acceleration is a rate of change in velocity. Okay, so this one here is very important. So this means now, if ever you have any object, let's say for example, your object is moving in a very slow pace, or it can either move in a very fast pace. So the rate at which is changing the speed, it can either increase its velocity or decrease its velocity, that will be called acceleration. So let me just make a clear example that is related to a projectile. So let's say, for example, we have a ball here, and then we are trying to project this ball upwards. So we know now this ball will initially move upward, but at the end it will come back to the ground. Because of what? Because of the force of gravity that I have already explained. So that means now this object is always accelerating downwards. So that means the velocity of this object will change, but the way it changes because it changes in a way that it is decreasing as it moves upward, because acceleration is doing what? Is always directed downwards, of which is a gravitational acceleration. I will actually explain this phenomena better when we move to the questions. Let's just move to the next point. Okay, so it's very much important to also what? Note that the direction of every vector is important, including the direction of the displacement. So let's say, for example, the very same example of projecting the ball vertically upwards. So if we project this ball vertically upwards, it will have an initial velocity. Let's say, for example, we project it with 10 meters per second. So the direction of this velocity, it will be upwards because the ball is projected upwards. Okay, but at the same time, there will be what? There will be an acceleration that is acting on an object that is actually decreasing the velocity of the object as it moves upwards. And then this gravitational acceleration, it has a value of 9.8 meters per second squared. And then its direction is always downwards. Okay, so when it comes to the displacement, let's say, for example, we are projecting a ball from a certain height, let's say it's 10 meters above the ground. So remember, the displacement actually means what? The initial point where the ball was and the final point where the ball will be. That is called the displacement. The displacement is different from a distance. Let's say, for example, we are projecting this ball upwards here, so that means it's going to move up, but because of gravity it will fall down. It falls down to the ground. So the displacement of this ball, it will be 10 meters, because the initial point and the final point is what determines the displacement, not the distance through which the ball will have traveled. So pay attention to say now, you must consider the direction at which this ball travels the displacement. So as you can see, the ball is starting up there and is moving down the displacement. So that means you will take what? You will take the direction of the displacement as downwards. So that means the displacement will be how much? Will be 10 meters, but it is downwards. Okay, so with this scenario, let's say now the question says now you must calculate the final velocity of the object as it hits the ground after 5 seconds. Let's say you are given that time to say after 5 seconds the ball will hit the ground. So calculate what? the final velocity as the ball hits the ground. Okay, so you know now you will have to select a suitable equation from the equations of motions. So let's say you have did that, you have applied that, but we're going to talk about this, and then you choose this formula to say the final velocity is equals to the initial velocity plus acceleration multiplied by change in time. Okay, so now the importance of direction, it comes to when you have to substitute these values here on the equations of motions. So if you get the direction of one vector, that means everything will be incorrect. So the direction is very much important. Every time when you write this equation of motions, you must indicate to say now, I'm taking downward direction as positive. Or you can take the upward direction as positive. It's really up to you, but the most important thing is that you must indicate to say now you are taking downward direction as positive. Okay, so we have the initial velocity of 10 meters per second, and then this velocity, remember, is moving upwards. As we start to project this ball, we are actually projecting it upwards, and then it's going to fall down to the ground. So the initial velocity has a direction of upward. So when we want the final velocity, we'll say final velocity is equals to, now the direction of the initial velocity is upward, and we say we are taking downward direction as positive. That means this velocity here will have a value of negative 10 meters per second, because its direction is upward and we said we are taking downward as positive. So it's very much important that you indicate these directions, because if you don't, you will get your answers incorrect. And then you move to acceleration. Remember, acceleration is always towards the center of the earth. That means it will always pull the object downwards. So now the acceleration, or the gravitational acceleration, always has the value of 9.8 meters per second squared, and its direction is always downwards. So when you substitute it here, you will also check to say, okay, I have indicated to say now I'm taking downwards direction as positive. That means I will substitute the value of acceleration as positive because the direction of acceleration is downwards. So I will have what? I will substitute acceleration as 9.8, and then I will also substitute the value of time, which is 5 seconds. So remember, time cannot be negative, so time will always be positive. Therefore, you get the value of your final velocity to say negative 10 plus 9.8 multiplied by 5, and then your answer is what? Is 39 meters per second. Okay, so now if you get your final velocity answer as positive, that means what? At the final point, your ball will be moving downwards. So as you can see here, the ball was initially moving up, and then it started to change direction, it moves downwards. That means here at the final velocity, the ball will be moving downwards. So it will be moving at a speed of 990 or 39 meters per second. Yes. Okay, I think that is all for today.